Okay, guys, little cool stuff here. Pascal's triangle and counting trees. First, counting trees, which I thought were neat. So you're doing a math, not math, art, not art tree. So kids can take math or not, and art or not. And the question is below here. Sorry, I forgot what I was doing. So you have 100 kids in total. 55 take math, so 55 take math, and 45 don't take math. We're going to fill this tree out. So this is a tree, but it has some kind of neat stuff in it and that we can count with it. So if I have 55 kids taking math and of the math students, 9 take art. So if you take math, 9 take art. We're going to keep going with this. If 9 take art, then that would mean that 46 do not. And it says that 30 kids in total take art. Well, 9 are here, so that would make 9 subtract, or 30 subtract 9, 21 here. And this is 45, 21 goes here. So how this works is 100 is split up in 55 and 45. This 55 is now split up in 9 and 46. This 45 is now split up in 21 and 24. So a question might be, how many kids don't take art? You could go that and that. Or how many kids don't take art or math? It would just be 24. Okay, so kind of neat stuff, I thought. That's a good way to keep track of stuff. Not testable material, but neat stuff. So what we're looking at here is Pascal's triangle, which looks something like this. Okay, and the reason we're doing this is that it corresponds to this. So if we look at permutations or combinatorics, really, sorry, let me kind of straighten this out, is this lines up like this. So let me go all the way down here. So here, if I go down to row 1, 2, 3, 4, 5, so now I'm down here, so it's C4, 0. Okay, so that 4 goes with that there. And that C4, 0 is 1, C4, 1 is 4, C4, 2 is 6, C4, 3 is 4, and C4, 4 is 1. And that's how they relate. Okay, so combinatorics go with Pascal's triangle that way. And if you remember from last year, why we use combinatorics is to, or sorry, why we use Pascal's triangle is to expand binomials that are higher powers than this. So what happens is when you expand x plus y to the 4, you can go to the 5th row of Pascal's triangle and then expand this. So this becomes C4, 0, x to the 4, y to the 0, plus C4, 1, x to the 3, y to the 1, plus 4C2, x squared, y squared, plus 4C3, x1, y cubed, plus 4C4, x to the 0, y to the 4. Now a lot of this gets cleaned up. This is 1, x to the 4, and that's also 1. So that just turns into x to the 4. That's 4, and x cubed y plus 4x cubed y. Just one thing here, if that was a 2x, let me just show you here. If you got here, it would be 2x to the 4, which would be 2x. Let me just write that, which is 2 to the 4 and x to the 4. So that's going to be 16 x to the 4. So if that happens, you're going to have to multiply this number here by whatever this is also. Okay, so it gets a little more complicated. Anyway, you just expand them and you get a nice pattern here. Now, what I'm going to ask you on the test is a question like this. So if I said, let's make it easy first, x plus y, just keep it simple, to the 7, and I said, what is the 4th term? Good. So the 4th term of x plus y to the 7. So you set this up like this, and then you just got to figure out what goes here, what goes here, what goes here, and what goes here. So it's 7, but I want the 4th term. So if you go back to this here, when that was a 4 here, all of these were 4s. So all of these would be 7, so that's definitely a 7. Where it gets tricky is if it's the 4th term, you want to put a 4 there, but let's go back here. The 4th term here, 1, 2, 3, 4. The 4th term is a 3, and why that is we start, the first term starts with a 0, then a 1, then a 2, then a 3, etc. So this is always going to be 1 less, so that goes here. Now this value here goes here. Okay, these are always the same. And then this one here is going to be 7 subtract 4. So 7 subtract 3. that, subtract that, we get to that. So then you figure out what that is, which would be what, 7 factorial over 4 factorial, 3 factorial, x to the 4, y cubed. Okay, and then you figure what that is, and then that's your answer. Let me do a harder one. 3x plus 2y to the 10. Okay, so that looks really hard, but what I'll do is this. Just nice and easy one. Give me the second term. Okay, so C, and then I have 3x and 2y, and I want this to the 10. That's a 10. Second term, remember, second means 1 here. That 1 goes up here, and then 10 subtract 1 goes here. Okay, you know what? Let's make our lives a lot easier. Let's just do this like that. Okay, so pretend it was just x plus 2y. So that is going to be 10 factorial over 9 factorial, 1 factorial. Okay, and that's just 10. And that's x to the 9, and 2y to the 1 is 2y, or 2y to the 1. And that then, now when we do this though, we have the 10 here, x to the 9, and 2y, and then that turns into 20, x to the 9y. Okay, so that's how that's expanded. So that's the sort of question I'm going to ask you on the test. Okay, and the last thing, we use Pascal's triangle. This is really neat. Pascal's triangle to figure out how many paths there are. So if I can only go right and up, and I want to figure out how I can get to each square, if I start here, I can only get here by going to the right. And then that kind of works its way through like this. And if I want to go here, there's only one way to get here. How do I get to this box? Well, I have to go from here and here, so that's here, right? Where it gets kind of cool is later on, is you start noticing these numbers kind of, well, they are Pascal's triangle. That's what we're doing. Okay. But if you ask yourself, how many ways can I get here? And I said there's 6 ways to get here. Well, why is that the case? Well, I can go from here and go all the way across. Let me do it this way. Here's one way. Okay, here's another way. 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 I think I got them all. So 6. So there's 6 different ways to do that. But another way to think of that is how many ways to get there? It's right, D, D. How many words can I make out of that? 4 factorial over 2 factorial, 2 factorial. Anyway, when you fill this up, it turns into being kind of Pascal's triangle. Okay, so this is, these 2 add up to this, these 2 add up to this. This is 5. Yeah, I didn't really say that, I don't think. So back to Pascal's triangle. The way you get to Pascal's triangle is these are all 1s. And then these numbers here are the addition of the 2 numbers above it. So for example, 3 and 3 is 6. So if I want to do the next row, I'd go 1, 1 plus 4 is 5, 4 plus 6 is 10, 10, 5, 1. Okay. And finally, where we get to the fun stuff is this here, where we have this checkers, and this here. So what's going on here? I can move here one way or one way. So playing checkers, you move diagonally up to the left or to the right. And then you say how many ways can you get to each spot. So here, I can only get here by going here. And then what happens is what you're going to add are the numbers below it. So it's kind of like Pascal's triangle flipped on its head. There's 1 and 1, they add up to 2. 2 plus 1 is 3. So there's 3 different ways to get here. Now what happens here is when I get to an x, I jump over it. So I don't put a 1 here, but I put a 1 here. It's like another, the other guy's character in checkers. You just kind of jump over them. And then from here to here is 3, but then when these guys meet up, it's 4. Okay, and that's 1, and 4 plus 1 is 5, and that's 3, but this is a neat one here. Jump over, so I have 3 and 3, because that's like this, they meet up, you get 6, and 3 and 3 here is 6, and you get, just plain 6, 12, add these up, add that up, like that. And then the question is how many ways can you get up here? You're just going to add those together. Okay, hope that made sense. Let's go.